Hi, this is a video that's going to help you to answer questions from the lab or activity that we called continuous and bright line spectrum. So if you missed that, one of the questions is about a continuous spectrum. So up here, this is what happens when you look through a spectroscope, which is kind of like a prism that breaks the colors apart. If you look at pure outside white light, this is what we saw. And then we also saw line emission spectrum, where we only saw certain bright lines appear for specific elements. This is kind of like a fingerprint for any given element. It'll only do certain transitions for its electrons, which will only give us certain exact colors. So then what we did is we are going to kind of draw this on an atomic scale. So I'm going to show you how to do one, and then you will still have to do the two that are on the lab write-up. So I'm going to show you, so I would label, whoops, not like that. So I would label, n equals 1 is just that first level, energy level. N equals 2, 3, 4, and then I'm going to add n equals 6. So if you have an electron, sitting at n equals 2, we would call that ground state. The electron is as close as possible to the nucleus, but then once we supply energy, and in this activity we used electricity, then the electron absorbed energy moved to a higher energy level. So I'm going to draw a photon. So a photon, like a violet photon, has a higher frequency, more energy than if I were to draw a red photon. So let's do the violet. So this photon will get absorbed by that electron, which will cause it to become excited. So it'll go up here, and I put a little thing around it just because it doesn't stay there very long. So that's showing you absorption. And then the electron, and then like I said, it's in the excited state. Then the electron will return back to ground state, and it'll undergo emission. It'll release that energy. And when it releases the energy, it's going to give us sometimes a color we can see. So the violet would be like a high frequency, small wavelength wave, compared to if you were to draw the red wave energy being given off. And then, blue would be somewhere in between.